In this video, I'm going to solve these two questions. So let's start with the first one. The table below has the results from a production efficiency analysis. The firm has 4 operators and 5 machines. Each of these are identified with a dummy variable. So we have 4 dummy variables over here. These are to identify the 4 operators. And we have 5 dummy variables over here. These are to identify 5 machines. Okay, I hope you have some basic idea of how to interpret dummy variables and how to read the naming of dummy variables. Over here, I'm also going to give you a quick overview just to avoid any confusion. Okay, so for the operators, we have these 4 dummy variables. So I've listed this dummy variables over here. So the first dummy variable is named as OP_1, and because it is named OP_1, this dummy variable will give the value 1 if we talk about operator 1, and it will give the value 0 to all the other operators. Okay. Similarly, if you take a look at the second dummy variable, it is defined as OP_2. So that's the name of your second dummy variable. It is going to give the value 1 to second operator and 0 to all the other operators. Similarly, the third dummy variable is OP_3. It is going to give the value 1 to operator 3 and 0 to all the other operators. And the fourth dummy variable is named as OP_4. It is going to give the value 1 to operator 4 and 0 to all the other operators. Okay, so this is how these 4 dummy variables are defined. Similarly, we have these 5 dummy variables over here, which are representing the machines. So the first dummy variable is MACH_1. This is going to give the value 1 if we are talking about machine number 1 and 0 if we are working with any other machine. The second dummy variable is MACH_2. This will give the value 1 if we are working with machine 2 and 0 for any other machine. The third dummy variable is MACH_3. This will give the value 1 if we are working with machine number 3 and 0 if we are working with any other machine. And similarly, you can also see for the dummy variable 4 and the dummy variable 5. The dummy variable 4 will give the value 1 if you are working with machine number 4, and the dummy variable 5 will give the value 1 if you are working with machine 5. Okay, so this is how you have to read these dummy variables. Now let's see what is it that they are asking us in the question. So they are asking us to estimate the hourly output. Well, as you can see, the dependent variable is hourly output. Okay, so that's what they are asking us over here, that we have to estimate the hourly output with 2-digit accuracy when operator 1 uses machine 3. Now, if you take a look at the output over here, the first thing that you should notice is that they have not taken OP_1 over here. So we are not working with this dummy variable. This is done to avoid dummy variable trap. Similarly, we are not working with MACH_1. So these two dummies are not a part of your regression output. So we can completely ignore these two dummies and we have to focus on the other dummies, right? So now let's take a look at the equation that we are given. So I'm going to write the fitted equation. So the way fitted equation is going to look like, it's going to be output hat equal to, I'm deliberately not writing numbers, I'm writing notations because it would be easier that way. So we can write output hat is equal to beta 0 hat plus beta 1 hat OP_2 plus beta 2 hat OP_3 plus beta 3 hat OP_4 plus beta 4 hat, so this is beta 4 hat MACH_2 plus beta 5 hat MACH_3 plus beta 6 hat MACH_4 plus beta 7 hat MACH_5. Okay, so this is the estimated equation. Now they are asking us that we are working with operator number 1 and machine number 3. So if you are working with operator number 1, you can see over here that if you work with operator number 1, all of these dummies are going to take the value 0. So for operator number 1, OP_2 is also going to take the value 0, OP_3 will also take the value 0, and OP_4 will also take the value 0. So that means over here we have a 0. So we are going to put a 0 over here as well and 0 over here as well. That means we are going to get rid of these 3. Okay. Similarly, we are working with machine number 3, and if you focus on machine number 3, MACH_2 is 0, MACH underscore 3 will take the value 1, and the other two dummies will also take the value 0. Okay, so instead of MACH underscore 2, we can put a 0 over here. So this term will go away. This term will remain because in place of MACH underscore 3, we are going to put 1. In place of MACH underscore 4, I'm going to put a 0. So again, this will go away. And in place of MACH underscore 5, I'm going to put a 0. So this will also go away. So in total, if you take a look at what is it that we are left with, we are left with output hat is equal to beta 0 hat plus beta 5 hat times 1. Okay, so this is what we are left with, right? And now we can just put the numbers over here. So that means the output hat is equal to, what's your beta 0 hat? Well, your beta 0 hat is this. So it is 9.91931. And what's your beta 5 hat? Beta 5 hat is your coefficient of MACH underscore 3. So beta 5 hat is this, 1.802726. And this is equal to 11.722. That means the correct answer is part B, 11.72. Okay, so this was the first question. Now let's move to the second question. So this is the second question. However, now in this question, we have to answer which is the least productive combination. So if you take a look at the dependent variable is hourly output. So we have to check the estimated hourly output for all these combinations, and then we have to see which combination is going to give the least estimated hourly output, and that's going to be your least productive combination. So we are going to check for all these combinations one by one. So if you take a look at the first option over here, it is operator 1 with machine 3. And if you take a look over here, we have actually done it, right? In the last question, we talked about what's going to be your estimated hourly output when you're working with operator 1 who is using machine 3. So the estimated output came out to be 11.72. So we don't have to do it again over here. From the last question, we know that the estimated output for this combination is going to be 11.72. Now let's move to the next combination. So the next combination is operator 1 with machine 1. So let's see what's going to be the estimated hourly output in this case. Once again, we have to ignore these two dummies because these are not there in the regression output. And now we are working with a combination when the operator 1 is using machine 1. Okay, so operator 1 uses machine 1. Let's see what's going to be the estimated hourly output. So when you're working with operator 1, as you can see, all of these dummies are going to take the value 0. So for operator 1, this is going to be 0, this is going to be 0, and this is going to be 0. So we can get rid of this, this, and this. Okay, now let's see what is the machine that we are working with. So we are working with machine 1. And if you take a look at the machine 1, all these dummies are equal to 0 for machine 1. Okay, so over here you can see it. So that means this is 0, this is 0, this is 0, and this is 0. So we can remove this, 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 this. So that means in this case, your estimated output is just equal to beta 0 hat, where we can see from this table that beta 0 hat is equal to 9.91931. Okay, so it's 9.91931. So let me put it over here that this combination is giving 9.91931. Okay, let's move to the next combination. The next combination is operator 3 with machine 1. So now we have to check for operator 3 using machine 1. Okay, so once again, you have to ignore these two dummy variables. Now, if you take a look at operator 3, for operator 3, this dummy is taking the value 0. So this dummy is taking the value 0. This dummy will take the value 1. And this dummy will take the value 0. Okay, so that means over here we have a 0. So this goes away. Over here we have a 1. So this is going to remain. And over here we have a 0. So once again, this is going to go away. Okay, now we are using machine number 1. So for machine number 1, you can see that all these dummies are taking the value 0. So for machine number 1, we have 0 over here, 0 over here, 0, and this is also 0. So this goes away, this goes away, this and this also goes away. Okay, so that means the estimated output is equal to beta 0 hat plus beta 2 hat multiplied by 1. So we can pick the value from this table. So beta 0 hat is 9.91931, and beta 2 hat, what is beta 2 hat? Beta 2 hat is the coefficient of OP underscore 3. So you can see from here that the coefficient of OP underscore 3 is minus 2.178451. Okay, so this implies that output hat is equal to 7.740. So let's write over here that this is 7.740, and now we have to check for the last combination, which is operator 3 with machine 3. So now we have operator 3 using machine 3. Okay, so once again, ignore these two dummy variables. If you focus on operator 3, this dummy variable is taking the value 0, this dummy variable is taking value 1, and this dummy variable is taking value 0. So this is 0, so this goes away. This is 1, so this is going to remain. And once again, this is 0, so this goes away. And we are working with machine 3. So when we are working with machine 3, this dummy variable will take the value 0. This dummy variable will take value 1. This will take a value of 0, and this will also take a value of 0. So this is 0, so this goes away. This is 1, so this is going to remain. This is 0, this goes away. This is also 0, this goes away. Okay, so that means the estimated output is going to be beta 0 hat plus, from here we get beta 2 hat multiplied by 1. So plus beta 2 hat multiplied by 1. And from here we get plus beta 5 hat multiplied by 1. Now we are going to put the numbers over here. So that means the output hat is equal to, your beta 0 hat is 9.91931. Beta 2 hat is the coefficient of OP underscore 3. So this is your beta 2 hat. So it becomes minus 2.178451. And beta 5 hat is the coefficient of MACH underscore 3. So the coefficient of MACH underscore 3 is this. Okay, so this is plus 1.802726. So when you solve this, you will get that output hat, that is your estimated output, is equal to 9.543. So now we can put over here that this is 9.543. And as you can see from here, that the least productive combination is going to be the one that is going to give the least estimated hourly output, and that's your path C. So the combination of operator 3 with machine 1 is giving you the least estimated hourly output. So this is the least productive combination. So that's your answer.